Welcome to qnawire.
So now we'll work on problem 46 from chapter 17. In this problem, we're asked to consider the titration of a 30.0 milliliters sample of 0.050 molar ammonia with 0.025 molar HCl. So we're supposed to calculate the pH after the volumes of titrant have been added. So first, let's calculate the amount of ammonia we have at the beginning. And so we multiply the concentration times the volume to get a value of 0.0015 moles of ammonia. So in part A, we're supposed to calculate the pH with 0 milliliters added, so we only have ammonia. So we make a nice table. NH3 plus H2O is in equilibrium with NH4 plus OH minus. So our initial concentration of ammonia is 0.05. And we subtract X. And add X to both sides. So we get an equilibrium of 0.05 minus X, X, so we can set this equal to the Kb, which is equal to 1.8 times 10 to the minus 5, which is equal to x squared over 0.05 minus x, which we disregard, and we get x is equal to 9.49 times 10 to the minus 4. And if we take the negative log of this, we get POH is equal to 3.02, and pH is equal to 10.98, which is our value of the pH for part A. In part B, we've added 20 milliliters of acid, so we calculate the moles of acid that we've added by multiplying the concentration times the volume. That gives us 0.0005 moles of HCl, which we can subtract from the moles of NH3 that we initially had to find the moles of NH3 that we have left. So this gives us a value of 0.001 moles of NH3 remaining. So we can go ahead and calculate a concentration from this by dividing by our new volume, which is 50 milliliters. And we get 0.02 molar. And then we look at we change our expression for Kb to be equal to 1.8 times 10 to the minus 5. And then we modify our initial concentration of ammonia to be 0.02 minus x. And x is now equal to 6 times 10 to the minus 4, which gives a pOH of 3.22 and a pH of 10.78. For part C, we do the same process. This time we've added 59 milliliters. So we calculate the added HCl to be equal to 0.00148 moles. So now we calculate the moles of NH3 left to be equal to 2.5 times 10 to the minus 5 moles of NH3. So then our Kb is unchanged, 1.8 times 10 to the minus 5. Our initial concentration of NH3 has changed to be 2.5 times 10 to the minus 5, all minus x. And that gives us a value of x is equal to 2.12 times 10 to the minus 5, which gives a pOH equal to 4.67 and a pH equal to 9.33. In part D, we calculate the moles of HCl added as being equal to 0.0015 moles. If we look back at the beginning here, this first calculation which we did, we see that this is the equivalence point. So now all of our ammonia has been converted to ammonium. So we calculate our concentration of ammonium by dividing the moles by the volume, and we get a value of 0.0167 moles. So we can calculate a Ka as being equal to 5.56 times 10 to the minus 10. And we can set this Ka equal to the equilibrium expression. We hit x squared over 0.0167 minus x. We disregard this minus x, and we get x is equal to 3.05 times 10 to the minus 6. And since we're dealing with an acid now, we can directly calculate pH as being equal to 5.52. In part E, we now have excess acid. So the moles of HCl, which are added in this case when we have 61 milliliters, is equal to 0.00153. And so we calculate the remaining after equivalence to be 0.00153 0.00003 moles, which we can put into we can divide by the volume, which is 0.091 liters, and we get 2.75 times 10 to the minus 4 molar. And if we take the negative log of that value, we get a pH is equal to 3.56. And the last part of this problem here asks us about uh, 65 milliliters. So this time it's possible for us to directly calculate the excess. Since we know that the equivalence point occurs at 60 milliliters, we can calculate the amount of moles that's in the excess 5 milliliters directly. And we get a value of 0.000125 moles of excess HCl. We could do that if we know the equivalence point for any volume above the equivalence point. And so we calculate the concentration by dividing these moles by the volume, which is 0.095 liters. And that gives us a value of 0.00132 molar. And this gives us a pH value when we take the negative log of 2.88.